Now let's look at a real world problem. Ava sets a goal, and this is on your notes. Ava sets a goal to read 12 books over summer vacation. That's a good goal. Ava expects to read 2 books each week. How many weeks will it take Ava to reach her goal? Now, I know you guys can read that and just say, okay, 12 books, starting with 12 books, reading 2 a week, it's going to take 6 weeks. 12 divided by 2 is 6. But I want you to see how this looks as a function. She's reading 2 books each week. The answer should be 6. Well, let's graph it. Let's think about the linear equation and see how much important information is in the graph and is in the linear equation. If I define my input, my independent variable, as the number of weeks that Ava is reading, and my output variable, my dependent variable, as the number of books left to reach her goal, the number of books she still needs to read to reach her goal, then I can graph this situation. So let's just pick a number, 1 week. She's been reading the books for 1 week. She reads 2 books each week. She started with 12 books, so after 1 week, she will have 10 books left to reach her goal. So we can graph that, 1, 10. 1 to the right and up 10. I should label, if I have a real situation like this, I should label the x-axis weeks, the number of weeks she's been reading, and the y-axis is books to goal, the number of books left to reach her goal. All right, after 2 weeks, she will have read 2 more books than this previous after 1 week, so she will have 8 books left. 2, 8. 2 to the right, up 8. After 3 weeks, we can decrease this again by 2 books because she will have read 2 more books. 3, 6. 3 to the right and up 6. There's something interesting happens when you draw this line. If I keep, it's so hard to draw a straight line on this writing tablet, but I really want this one to be as perfect as possible. Let me do my best here. If I extend this line, if I keep going, we see that at 6 weeks, she'll have 0 books left to reach her goal. She will have reached her goal at 6 weeks, as we expected. So this is called the x-intercept, and you don't often, you much more often hear about y-intercept than x-intercept, but they both have meaning. You see here that the meaning of the x-intercept, where the line intersects the x-axis, it tells you there's 0 books left to read, she's reached her goal, and the amount of time is 6, so that would be the answer to the question. But something else interesting happens when you extend this line in the other direction. You see that Bill Gates, we see that the line also intersects the y-axis right here. So let's think about the meaning of that point. 0, 12. When x is 0, at 0 weeks, the books she needs to reach her goal is 12. Well, that makes sense too, right? Because before she starts reading, the time is 0. That's the starting point. And she hasn't read any books yet because she hasn't had any time to read any books. So at time 0, at 0 weeks, the y-intercept shows you how many books she started with. So both intercepts have meaning. We said that we said that b is the y-intercept, and b in this case is positive 12. It's the value on the y-axis where the line intersects the y-axis. So b is 12. Now, I'm getting ahead of myself, but I want to give you a little preview of Wednesday's lesson. The slope is the ratio. Let me get a different color. The slope is defined as delta y over delta x. If I go from one point, like this point, to another point, if I move from this point to this point, I need to go down 2 in y, negative 2, and then 1 to the right in x, so positive 1. And negative 2 divided by positive 1 is negative 2. So when we look at slope-intercept form, y equals mx plus b, I can see that the equation of this line is y equals negative 2, because the slope m is negative 2, times x plus the y-intercept is 12. So y equals negative 2x plus 12. If you want to check me, you can substitute some of the values that we've already found into this equation, and you'll see that they match. The output will match as it should. And so that's sort of like a sneak preview of what's coming. But for now, your learning opportunity looks like a lot like the first 3 examples we did for problems 1 through 6. So choose an input, calculate an output, graph the point. And then I've got a question for you to answer, and then 3 graphs where you tell me it's a function or it's not a function using that vertical line test that we explored in the notes. All right, class dismissed.